Welcome to the Deep Dive. Today we're tackling a really interesting corner of the financial world, something incredibly powerful, maybe a bit opaque. We're talking about credit rating agencies, CRAs.
That's right. These are the companies, the private firms that stick those letter grades, AAA, BBC, onto debt instruments, bonds mostly.
And what does that grade actually mean?
It's basically their assessment, their prediction, really, of how likely the borrower could be a big corporation, could be a whole country, is to pay back their debt, how likely they are to default.
Okay, so our mission today is to unpack this. How did these few companies get so powerful, so indispensable, especially when you think about the 2008 financial crisis?
Right, where their ratings were, frankly, disastrously wrong on a massive scale.
Exactly. Hundreds of billions in top-rated securities just collapsed. Yet somehow, the same few players still dominate everything. That's what we need to dig into.
It really is an extreme concentration. We talk about the big three, that's Standard & Poor's, S&P, Moody's, and Fitch Ratings.
The big three.
Yeah. And together, they control something like 94% of the entire global ratings market. It's astonishing.
94%. So their opinion isn't just an opinion, it's almost like a passport for getting funding.
Pretty much. In many ways, it's a necessary condition for accessing capital markets, especially for big players.
All right, let's go back. How did we get here? How did these, essentially, private companies end up as these global financial gatekeepers? The story doesn't start with complex bonds, does it? It's more basic.
Much more basic. You have to go back to the mid-19th century in the U.S. Think about the panic of 1837.
Yeah.
After that, the U.S. economy was expanding, trade distances were getting longer, merchants in, say, New York were dealing with customers hundreds of miles away they'd never met.
Right. You don't know who you can trust, who's good for the money.
Exactly. You needed reliable information, intelligence, really, on creditworthiness. Personal knowledge wasn't enough anymore.
So that's where the first agencies came from, like Lewis Tappan's back in 1841.
Precisely. But these early ones, like Tappan's Mercantile Agency, they were focused on rating individual merchants, their character, their business prospects, almost like private investigators for credit.
Okay, so rating people, not paper. When did the shift happen towards rating securities like bonds?
That came later, around the turn of the 20th century. The big driver was the explosion of the U.S. railroad industry.
The railroads. Huge amounts of capital needed.
Massive amounts. They issued enormous quantities of bonds to finance construction, and investors, many of them far away, needed some way to judge the risk of these different railroad bonds.
Makes sense. So someone steps in to provide that analysis.
John Moody. That's the key name here. In 1909, he published his first manual, Moody's Analyses of Railroad Investments. It focused only on railroad bonds.
Okay.
And crucially, a few years later, by 1913, he started using that simple letter grade system, A, BA, and so on. It was accessible, easy to understand.
Right. The same basic system we still see today. But, having an opinion, even a respected one, is different from having legally mandated power. When did that happen?
That's the critical pivot. It happened in 1936, in the wake of the Great Depression. The government was desperately trying to make the banking system safer.
Through the Glass-Steagall Act.
Exactly. Part of that included new rules from banking regulators, like the comptroller of the currency. They said U.S. banks could not invest in bonds that were considered speculative investment securities, basically junk bonds.
Okay, logical enough. But who decided what was speculative?
Well, the regulations specified that the determination should be made by reference to recognized rating manuals, and whose manuals were recognized.
Let me guess. Moody's, Poor's, which became S&P, and Fitch.
You got it. Suddenly, these private companies' ratings weren't just advice anymore. They were effectively written into law. They became mandatory hurdles for bank investments.
Wow. So the government didn't set up its own rating system. It just pointed to these private firms and said, their opinion is now part of the rules.
That's essentially what happened. It cemented their power. It wasn't just market respect anymore. It was regulatory necessity. They became the arbiters of risk for huge pools of institutional money.
Okay, so they've got this government-backed authority. Let's talk about how they make money. Because the way that changed seems absolutely central to the problems that came later.
It absolutely is. For decades, the model was simple. Investors paid. If you wanted the ratings reports, the analysis, you bought a subscription.
The investor pays model. Seems logical. The person using the information pays for it.
It does. But then came a technological disruptor, the photocopier.
The Xerox machine.
Exactly. By the late 1960s, early 70s, it became incredibly easy to just photocopy the rating reports and pass them around. This created a massive free rider problem.
Meaning people could get the information without paying the subscription fee?
Right. And it started to really hurt the CRA's revenue, so they made a fundamental switch.
To the issuer pays model.
Correct. Around the early 1970s, they flipped the model. Now, the entity issuing the debt, the company selling bonds, the government borrowing money, pays the rating agency a fee to get their debt rated.
Okay, stop right there. The company wanting the good grade pays the grader. That sounds like a conflict of interest waiting to happen.
It's the core conflict. The inherent structural conflict of interest that plagues the industry to this day. The incentives are immediately skewed. The CRA is getting paid by the very entity it's supposed to be objectively evaluating.
The customer is the one being rated.
Precisely. And the actual users of the ratings, the investors, the pension funds, the insurance companies who rely on that grade to make decisions, they're not the primary paying customer anymore.
Okay, let's quickly break down those grades. Why does getting that AAA matter so much?
Well, the letters signify different levels of risk. AAA from S&P or Fitch, or A from Moody's, that's the absolute top grade. It signifies an extremely strong capacity to meet financial commitments. Basically, as safe as it gets outside of maybe government bonds.
And the risk goes up as the letters go down.
Significantly. If you look at historical default rates over, say, a 5-year period, Moody's data shows defaults are tiny, like 0.18%. But drop down to BA2, still investment grade, mind you.
Still considered relatively safe.
Right. But the 5-year default rate jumps to over 2%. Then you get into speculative or junk territory, a B2 rating. That has historically seen a default rate of over 31% within 5 years.
Wow. Okay, so that risk has a direct impact on how much it costs to borrow money, right?
Absolutely. It's all about the spread. The extra interest you have to pay compared to a super safe benchmark, like a U.S. Treasury bond.
So a top-rated company pays less interest.
Much less. A AAA corporate bond might only have to pay, say, 43 basis points more than a Treasury.
And just quickly, 43 basis points is 0.43%.
Correct. But if you're down in junk territory, maybe a CCC rating, the spread could be enormous, maybe 724 basis points.
So 7.24% more interest than the government pays. That's a massive difference in borrowing costs.
Huge. It can mean millions, even billions in extra interest payments over the life of a bond. So that rating is incredibly valuable to the issuer, which again feeds back into that issuer pays conflict.
And this whole system gets another layer of official blessing in 1975, doesn't it, with the SEC stepping in?
Yes. The SEC formalized the concept of the Nationally Recognized Statistical Rating Organization, or NRSRO.
NRSRO. Okay, what does that designation do?
It essentially creates an official club. Only NRSRO's ratings can be used for certain regulatory purposes in the U.S., and this concept spread globally. Think about international banking rules like the Basel Accords.
Basel III, for example.
Right. These global regulations often hardwire NRSRO ratings into their capital requirements for banks. They also dictate what kinds of securities large institutional investors, pension funds, insurance companies are allowed to hold.
So regulations might say a pension fund can only buy bonds rated, say, A or higher by an NRSRO.
Exactly, or maybe BBB or higher. The point is, the regulations create mandatory demand for the ratings from these specific designated agencies. It's not just market convention, it's regulatory compulsion.
Which makes that NRSRO designation incredibly valuable and a massive barrier to entry for any potential competitors.
It's the moat around the castle. It protects the big three's oligopoly. They have this government-granted essential role in the plumbing of the entire global financial system.
Okay, so we have this entrenched oligopoly, the big three, protected by regulation, funded by the companies they rate. What could possibly go wrong?
Well, as we saw in the 2000s, quite a lot, especially with the rise of complex financial products, specifically structured finance.
Structured finance. Things like mortgage-backed securities, CDOs, the stuff at the heart of the 2008 crisis.
Exactly. This became a massive growth area for the rating agencies. Huge fees involved. These products were inherently complex. Banks would pool together thousands of loans, mortgages, car loans, credit card debt.
Often subprime mortgages, right?
Yeah.
Loans to borrowers with poor credit history.
Yes, that was a huge part of it. They'd pool this risky debt and then slice the pool into different layers, different tranches.
Tranches. I've heard it described like cascading water buckets.
That's a good analogy. The idea is money flows into the top bucket first, losses hit the bottom bucket first. So the top tranche, the most senior one, is the last to absorb any defaults from the underlying loans.
And because it's the last to take a hit, It's considered the safest part of the pool.
Theoretically, yes. And this slicing and dicing allowed banks to take a pool of pretty risky loans and somehow create a top tranche that the rating agencies could stamp with a AAA rating.
Even though the underlying ingredients were iffy.
Precisely. And getting that AAA rating was crucial because it made these securities eligible for purchase by all those big institutions, the pension funds, the insurance companies that were restricted by regulations to holding only top-rated debt.
Right. The NRSRO rules created the demand.
And here's where the issuer-pays conflict got really toxic. Sources suggest the CRAs weren't just passively rating these complex structures.
What do you mean?
They were often deeply involved in the design process. Investment banks would pay the CRAs not just for the final rating, but essentially for consulting work, for advice on how to structure the deal, how to arrange the tranches, specifically to achieve the desired high rating.
Wait, so the rater was advising the issuer on how to get a good grade from the rater?
Yes. Critics called it ratings shopping, or even ratings laundering. The banks knew what rating they needed to sell the product, and the agencies, paid by the banks, arguably helped them get there. The incentives were completely aligned towards producing high ratings, perhaps regardless of the true underlying risk.
That seems fundamentally broken. Were there warning signs before the big mortgage meltdown?
There were. Look at corporate bankruptcies. Enron is a classic example. A massive company, complex accounting.
And the rating agencies.
They kept Enron at investment grade until just 4 days before it filed for bankruptcy in December 2001, long after the stock price had collapsed and serious questions were being raised. It suggested the agencies were reactive, not predictive.
The canary in the coal mine sang after the mine collapsed.
Pretty much. But the subprime crisis was the systemic failure. The scale was just breathtaking. Critics called the ratings catastrophically misleading.
Give us the numbers again. They're staggering.
Okay, get this. Moody's rated over $800 billion worth of mortgage-backed securities as AAA in 2006 alone, the highest possible rating.
$800 billion, okay.
Within 2 years, by the time the crisis hit full swing in 2008, Moody's had downgraded 73% of those supposedly super safe AAA securities to junk status.
73%. From the safest rating to junk in 2 years. That's not a small error. That's a fundamental failure to assess risk.
It's an almost unbelievable level of inaccuracy on a product that was central to the global financial system. And it wasn't just mortgages. The CRA's influence and their perceived failures extended to governments, too.
During the European sovereign debt crisis that followed.
Exactly. When agencies like S&P downgraded countries like Greece, Portugal, Ireland, often quite sharply, EU officials at the time were furious. They accused the agencies of accelerating the crisis, of making borrowing costs skyrocket for these countries precisely when they were most vulnerable, potentially turning a manageable problem into a full-blown catastrophe.
Yeah.
It showed just how much power these unelected private companies held over the fate of entire nations.
Given that scale of failure, the Enron blindness, the $800 billion subprime disaster, the accusations around the sovereign debt crisis, you'd think the CRAs would have faced massive legal challenges, lawsuits everywhere.
They did face lawsuits, many of them, but they had this incredibly effective, some would say outrageous, legal defense.
Which was?
They argued, successfully in many U.S. court cases, that their credit ratings are not statements of fact about creditworthiness.
They're not facts. What are they then?
They argued they are statements of opinion protected as free speech under the First Amendment of the U.S. Constitution.
Hold on. Their entire business model, their regulatory standing, is based on providing what everyone treats as expert, factual analysis of risk. But when sued, they say, oh no, that was just like our opinion, man.
That's essentially the argument they made, and largely won on. It meant that proving liability was incredibly difficult. You couldn't just show the rating was wrong. You'd potentially have to prove malicious intent or recklessness, a much higher bar. It allowed, for example, S&P to get something like 41 post-crisis lawsuits dropped or dismissed based on this First Amendment defense.
That's just remarkable. A legally mandated opinion.
It created a huge shield. Now, the government did try to address some of this in the Dodd-Frank Wall Street Reform Act in 2010, passed in response to the crisis.
What did Dodd-Frank try to do?
A few things. One was transparency. It required the CRAs to be more open about their methodologies and, crucially, to publish historical data on the accuracy of their ratings over time. How often did their AAA bonds actually default compared to their B-rated bonds, for example?
So sunlight as a disinfectant. Let people see the track record.
That was the idea. Dodd-Frank also tried to tackle that First Amendment shield. It included provisions aimed at removing that special opinion status and holding ratings agencies to the same kind of liability standards as other financial experts like auditors or investment bankers. If they make false or misleading statements, they could be sued more easily.
Okay, that sounds like a significant change. Did it work?
Well, the implementation has been challenging, let's put it that way. There's been intense lobbying, disagreements between the SEC, which regulates them, and the agencies themselves about how exactly those liability rules should work. Progress has been very slow. The legal shield, while weakened perhaps, hasn't vanished.
And here's the kicker, right? Despite everything, the crisis, the bailouts, the regulatory reforms, the actual market structure hasn't really changed.
That's the profound irony. You had senators calling their performance horrendous, an absolute disaster. You had the Financial Crisis Inquiry Commission pointing fingers directly at them, and yet
The big three still dominate.
completely. Before the crisis, the big three had about 98% of the market share. After the crisis, after all the reforms, it dropped to maybe 97%. It barely budged.
They lost essentially nothing in terms of market power.
Nothing. It speaks to the power of that regulatory moat, the NRSRO system. Warren Buffett famously described Moody's business as a natural duopoly alongside S&P with incredible pricing power. He recognized that regulatory reliance makes their position almost unassailable.
Because institutions have to buy their product regardless of past performance.
To a large extent, yes. Which brings us to the ongoing debate about what, if anything, should be done now. If reforms haven't broken the oligopoly, what's the answer?
What are the main proposals out there?
Well, one school of thought says the problem is the regulatory reliance itself, so just get rid of the NRSRO rules altogether.
Eliminate the mandate.
Yes, stop hardwiring ratings into regulations. Force investors, pension funds, banks to do their own credit analysis or find other ways to assess risk. Don't give the big three this government-sponsored advantage.
That sounds like a radical shift. What are the alternatives?
Others propose hybrid models. Maybe keep the issuer pays system for the initial rating, because issuers argue they need some way to signal quality, but perhaps require a secondary validation funded by investors.
So a second opinion paid for by the users.
Something like that. Or maybe look towards public utility models, though that raises its own questions about government influence. There are also ideas about using technology, like crowdsourced ratings platforms, maybe something like a wiki rating approach, though scaling and validating that is tough.
So lots of ideas, but no easy answers, and the oligopoly remains firmly in place.
That really sums it up. We've seen how these agencies grew from basically credit detectives for merchants
Right, back in the 1800s.
to becoming these indispensable cogs in the giant machine of global finance. They provide a service that the market clearly needs, a standardized way to assess credit risk, which helps money flow more easily.
Liquidity, making it easier to buy and sell debt.
Exactly, that's hugely important. But at the same time, their dominant business model, issuer pays, creates this unavoidable conflict of interest.
A conflict that, as we saw vividly in 2008, can contribute to systemic, absolutely catastrophic failures when incentives align the wrong way.
And the central tension is still right there. Every major bank, every pension fund, every insurance company, every sovereign government issuing debt, they all still operate in a world heavily influenced, if not dictated, by the opinions of these three highly profitable private American companies.
So here's the thought to leave you with. Given that this oligopoly seems almost indestructible, and the global financial system remains so deeply reliant on their ratings despite past failures, is this just the way it is? Should the world accept that our understanding of who is creditworthy, from the biggest corporation to entire countries, will always be filtered primarily through these three conflicted private gatekeepers? Or is some kind of fundamental disruption, maybe towards more public oversight or radically different models, not just possible, but eventually inevitable?
A big question, something to think about next time you see a headline about a company or a country getting upgraded or downgraded. Thanks for taking this deep dive with us. Okay, let's unpack this. Welcome to the deep dive, where we really dig into complex source material to, well, give you the ultimate shortcut to being well-informed. Today, we are tackling a concept so fundamental, it basically defines life on Earth: photosynthesis.
Yeah, it's one of those things, isn't it? We probably all learned the basics in high school. Sunlight plus water equals food, something like that.
Hmm.
But the reality is just, well, it's an amazing piece of molecular engineering. We're talking billions of years of evolution, even quantum physics playing a role. It's pretty incredible.
Exactly. And that's our mission today, to push way beyond that simple definition. We've pulled together some really dense sources. We want to look at the actual machinery inside the cells, trace how scientists figured this all out over centuries, and explore some of the, frankly, ingenious ways organisms have adapted to make this work under tough conditions. We're really peeling back the layers on the engine that powers, well, everything.
And before we zoom right into the leaf structure, it's worth just pausing to appreciate the sheer scale of this. I mean, globally. At its heart, photosynthesis is how certain organisms, plants, algae, cyanobacteria, the autotrophs, take light energy and convert it into chemical energy. Stored energy, basically, in organic compounds like sugars. The main type, the one that supports us, is oxygenic photosynthesis.
Oxygenic, that's the key, isn't it? Because of the oxygen.
Absolutely crucial. It's called oxygenic because it splits water molecules to get electrons. And that process releases free oxygen, O2, as, well, a waste product, really. But that waste is what created and now maintains the oxygen levels in our atmosphere. It provides the energy source indirectly for almost all complex life.
So it's the planet's master energy producer. And the figures, when you look at them in the source material, are just mind-boggling. What is it, about 130 terawatts of energy captured globally?
That's the average rate,
Yeah.
130 terawatts.
Yeah.
And to put that into context for you, that is roughly 8 times the total power consumption of all human civilization.
Wow, 8 times.
Every power plant, every car, every phone charger, everything we run constantly. Nature's doing 8 times that, just passively soaking up sunlight.
That really puts things in perspective, doesn't it? Our entire industrial output versus this quiet, natural process.
It does offer a bit of humility. And it's not just energy. We're talking about these organisms pulling somewhere between 100 and 115 billion tons of carbon out of the atmosphere each year and turning it into biomass.
Billions of tons.
It's the dominant carbon cycle on the planet. The biggest factory and the biggest battery charger, all running continuously for eons.
Okay, so let's zoom in now from that massive global scale down to the nitty-gritty, the core chemistry and the cellular machinery that actually runs this 130 terawatt engine. What are the basic chemical steps?
Well, if you look at the general idea first, photosynthesis is always what chemists call a redox reaction. Oxidation and reduction happening together. You need carbon dioxide, you need an electron donor, let's just call it H2A for now, and you need light energy. And what you get out is a carbohydrate, like a sugar, which is the stored energy, plus whatever's left over from the electron donor after it's been oxidized, and some water.
And for the type we mostly care about, the oxygenic type, the H2A, the electron donor, is just plain old water, H2O.
Exactly. So the net reaction we usually see written down is CO2 plus water plus light gives you carbohydrate and oxygen gas. Although it's kind of interesting, water gets consumed in the first stage, the light reactions, but then a little bit of water is actually produced again later on. So it appears on both sides if you break it right down.
Ah, okay. And thinking about this energetically, it really highlights that fundamental split in the biosphere, doesn't it? Photosynthesis reduces CO2, locks energy into carbs.
While cellular respiration does the exact opposite. It oxidizes those carbs back to CO2 to release the energy.
Right. Photosynthesis is like charging the battery.
And respiration is using the battery. Happens in nearly everything, including the plants themselves, of course. They respire too. They're distinct processes, usually in different parts of the cell. But that charge-discharge cycle powers almost the entire living world.
So where does the charging happen? Inside the plant cell, we need to look at the chloroplasts. What's the setup inside these little powerhouses?
Right, the chloroplast. It's this specialized organelle, like a tiny bag within the cell, enclosed by a double membrane, an inner and an outer one. Inside that, there's this fluid-filled space called the stroma. That's where the sugars actually get built. And floating in the stroma, you have these stacks of flattened sacs. Those are the thylakoids.
And the thylakoids are where the action really starts.
That's where the light capture happens, yeah. They're often stacked up like coins into structures called grana. Just means more surface area packed into a small space. The thylakoid membrane itself is studded with all the important bits: the chlorophyll, the other pigments, the photosystems, the electron transport chains, everything for the light reactions. All that folding is basically biological architecture to maximize light harvesting and create the electrical and chemical gradients needed.
And in organisms that don't have chloroplasts, like cyanobacteria, They essentially do the same thing, but by folding their own cell membranes, right? Creating those internal membrane layers.
Precisely. Same principle. Maximize the working surface area. Now, to actually catch the light, you need pigments. The main one, the star player, is chlorophyll. Chemically, it's related to the heme in our blood, but built around magnesium instead of iron. It's really good at absorbing red and blue light.
Which is why plants look green to us. They're reflecting the green light. They don't absorb as much.
Exactly. But chlorophyll isn't working alone. Plants also use accessory pigments like carotenoids, carotenes, and xanthophylls.
To sort of broaden the range of light they can use.
Yeah, to fill in the gaps in chlorophyll's absorption. They grab wavelengths chlorophyll misses and funnel that energy towards the reaction center where the chemistry kicks off. We call the total range they can use the action spectrum.
Can you give an example of how that adaptation helps in a specific environment?
Sure, think about red algae. They often live deeper in the ocean than green algae or plants. Red light, which chlorophyll absorbs well, gets filtered out pretty quickly by water, but blue-green light penetrates deeper. So red algae have these accessory pigments called phycobilins, like phycoerythrin, which are excellent at absorbing that blue-green light. It allows them to thrive down where other photosynthesizers would struggle for energy. It's a neat evolutionary trick.
Okay. That sets the stage nicely, the structures, the pigments. Now let's get into the actual process, which happens in two main stages. The light-dependent reactions first, and then the light-independent reactions. Let's start with the light reactions. This is where the photons come in.
Right, this is where the physics really hits the biology. A chlorophyll molecule, usually in a large antenna complex, absorbs a photon. That energy gets passed around incredibly quickly, like a hot potato, until it reaches a special chlorophyll pair in the reaction center. This excites an electron in that chlorophyll to a much higher energy level. It basically gets ejected and immediately grabbed by an acceptor molecule. That's what starts the electron transport chain.
And this whole pathway is often drawn as the Z scheme, which I think is a helpful visual. It looks like a sideways Z if you plot the electron's energy level.
It is helpful, yeah, because the electron gets a big energy boost from light at photosystem 2, PSII, then it sort of cascades down an energy slope, doing work along the way.
Doing work like pumping protons.
Exactly. And then it reaches photosystem I, PSI, where it gets another big energy boost from more light before going down a final slope, hence the Z shape.
Okay, let's trace that path. Starting at photosystem 2, PSII, light hits it.
Light hits PSII, the electron gets energized and jumps out. As it moves along the first part of the electron transport chain towards PSI, the energy it releases is used by protein complexes to pump hydrogen ions, protons, H+ from the stroma, into that enclosed thylakoid space, the lumen.
Right, so they're actively stuffing protons into that tiny thylakoid sac, building up a concentration.
A very high concentration. And also an electrical charge difference across the membrane. It's called a chemiosmotic potential or proton motive force. It's stored energy like water behind a dam.
And the only way for those protons to flow back out down their concentration gradient is through a specific channel.
Yes, through a remarkable enzyme embedded in the membrane called ATP synthase. As the protons rush through it, they literally cause part of the enzyme to spin. And that rotation drives the synthesis of ATP adenosine triphosphate, the main energy currency of the cell, from ADP and phosphate. This whole process is called photophosphorylation, making ATP using light.
Okay, so PSII uses light to make the proton gradient that makes ATP. But wait, when that first electron left PSII, what filled the hole it left behind? PSII needs another electron to keep going.
Ah, yes. That's maybe the most crucial step for life as we know it. PSII replaces its lost electron by ripping electrons away from water molecules. This is called water photolysis, splitting water using light energy.
And that's catalyzed by a special complex?
Yes, the oxygen-evolving complex. It contains manganese and calcium ions, and it's the site where water H2O is oxidized. The electrons go to replace those lost by PSII. The protons, H+, are released into the thylakoid lumen, adding to that gradient we just talked about.
And the oxygen atoms combine to form O2?
Molecular oxygen, which is released as waste, that's the oxygen in our air. It's literally the leftover junk from replacing electrons in PSII.
Amazing. So the oxygen we depend on is just biological exhaust. Okay, so we've got ATP made. What about the other energy molecule needed for making sugars, NADPH?
Right. That's the job of photosystem I, PSI. The electron, after traveling from PSI and helping pump protons, arrives at PSI. It's now low energy again. But PSI absorbs another photon of light, which re-energizes the electron to a very high level once more. This highly energized electron is then passed down a second, shorter electron transport chain. Its final job is to reduce NADP plus nicotinamide adenine dinucleotide phosphate, to NADPH. NADPH is basically carrying high-energy electrons for later use.
And we should quickly mention that pathway we just described, PSI to PSI, making ATP and NADPH, that's the non-cyclic pathway.
Correct. There's also a cyclic pathway where electrons energized by PSI can, instead of making NADPH, loop back to the first electron transport chain near PSII. This loop just pumps more protons, generating only ATP without making NADPH or splitting water. It allows the cell to adjust the ratio of ATP to NADPH production depending on its needs. It adds flexibility.
Got it. So the light reactions have done their job, captured light energy, used it to make ATP and NADPH, and released oxygen. Now, stage 2, the light-independent reactions, sometimes called the dark reactions.
Yeah, that name's a bit misleading because they don't require darkness, they just don't directly use light. They happen in the stroma, the fluid outside the thylakoids, and they run as long as the light reactions are supplying them with ATP and NADPH, which is usually during the day. This is where the cell actually builds carbohydrates. It's the Calvin cycle.
Named after Melvin Calvin, and this is the part that actually fixes carbon from the air.
Exactly. Carbon fixation. This is where atmospheric CO2 gets incorporated into an organic molecule. And the key enzyme doing this job is the famous rubisco.
Ah, Rubisco, the hero and sometimes the villain of this story.
You could say that. Rubisco stands for ribulose 1-fibryl-5-bisphosphate carboxylase oxygenase. Its main job, the carboxylase part, is to grab a molecule of CO2 and attach it to a 5-carbon sugar called ribulose 1,5,bisphosphate, or RoBP. This forms a temporary 6-carbon molecule that immediately splits into 2 molecules of a 3-carbon compound, 3-phosphoglycerin.
And because the first stable product has 3 carbons, plants that primarily use this pathway are called C3 plants.
That's right. Now, the rest of the Calvin cycle is basically using the ATP and NADPH generated by the light reactions to convert these 3-carbon molecules into actual sugars. Specifically, they get reduced and rearranged into a 3-carbon sugar phosphate called glyceraldehyde 3-phosphate, or G3P.
This sounds like some serious molecular accounting.
It is. For every 6 molecules of G3P produced by the cycle, only 1 represents a net gain for the plant. The other 5 G3P molecules absolutely have to be recycled, using more ATP to regenerate the original 3 molecules of the 5-carbon RuBP starter compound. This keeps the cycle going.
So 5 out of 6 are reinvested just to keep the factory running. The profit margin is only 1 G3P molecule per turn.
3 turns of fixing CO2, technically, but yes, that 1 extra G3P is the entire output. That's what the plant then uses to make glucose, fructose, sucrose for transport, starch for storage, cellulose for structure, plus all the precursors for fats, proteins, everything else it needs. It all comes from that 1 net G3P molecule emerging from the Calvin cycle. It's the foundation of pretty much every food web on Earth.
The sheer complexity here really makes you think about the evolutionary journey. I mean, this wasn't designed overnight. The sources mention the earliest forms didn't even produce oxygen.
Absolutely. The earliest photosynthetic life probably emerged well over 3 billion years ago, long before the atmosphere had significant oxygen. These were anoxygenic photosynthesizers, like the purple sulfur bacteria you still find today. They didn't use water as their electron donor. They used things like hydrogen sulfide, H2S, from volcanic activity.
Releasing sulfur instead of oxygen?
Exactly. Or maybe just hydrogen gas, H2.
Yeah.
They use simpler systems, often just one photosystem, to generate energy. And there might be an even older, even simpler form. Some archaea, like Halobacterium, use a pigment called bacteriorhodopsin. Light hits it, and it directly pumps a proton across the membrane.
No electron transport chain.
No complex chain, no carbon fixation usually, just direct, light-driven proton pumping to make ATP. It's so basic, it possibly dates back to the Paleoarchean era. There's this idea called the purple Earth hypothesis, suggesting the very earliest life might have used pigments like this, making the planet look purple from space instead of green.
Fascinating. But the real revolution, the one that utterly changed the planet, was when cyanobacteria figured out how to use water.
That was the game changer. Around maybe 2.4 billion years ago, maybe earlier, cyanobacteria evolved photosystem II and the oxygen-evolving complex. Suddenly, they had an almost unlimited electron source water available everywhere. But the byproduct, oxygen, was toxic to most life at the time. Its buildup led to the Great Oxidation Event.
Sometimes called the oxygen catastrophe.
Right. It caused mass extinctions of anaerobic organisms, but also paved the way for the evolution of respiration, and eventually complex multicellular life like us, which needed that oxygen.
So we have this incredibly powerful planet-altering engine, refined over billions of years. But then we hit that efficiency paradox. The sources say plants typically only convert about 3 to 6% of the absorbed sunlight into biomass energy. Why so low if it's so refined?
Yeah, that 3–6% is a realistic average for actual field conditions. The theoretical maximum is higher, maybe 11% or so. But lots of things limit it. Only certain wavelengths of light are used, a lot is reflected or transmitted, and real-world factors like temperature, water availability, and CO2 levels often aren't optimal. Much of the absorbed light energy that isn't used chemically just gets dissipated as heat. But here's the amazing part. The initial step, capturing that photon energy and getting it to the reaction center, that part is incredibly efficient, almost perfectly efficient, thanks to quantum mechanics.
Okay, let's get into this quantum aspect. It's kind of mind-blowing that quantum effects are happening in like every leaf right now.
It really is. When a pigment molecule absorbs light energy, it creates this excitation, sort of energy packet, called an exciton. This exciton has to travel through the network of antenna pigments to reach the reaction center extremely quickly. We're talking femtoseconds to picoseconds. If it takes too long, the energy will just be lost as heat or light. Now, because the exciton has wave-like properties, it doesn't just randomly bounce around hoping to find the reaction center.
It does that quantum walk.
Exactly. It behaves as if it's exploring multiple pathways simultaneously due to quantum superposition and coherence. This allows it to effectively find the most direct and efficient route to the reaction center almost instantaneously. It's a way of minimizing energy loss during that crucial first transfer step. And it happens at warm, messy biological temperatures, which is what baffled physicists for a while.
So the very front end, the light harvesting and delivery, is near perfect because of quantum weirdness. But if that part's so good, where does the massive inefficiency come from later on? Why only 3–6% overall?
Well, a big part of that bottleneck brings us back to our friend Rubisco, the enzyme that fixes CO2. Its problem is that O in its name, oxygenase.
Right. It sometimes grabs oxygen instead of carbon dioxide, photorespiration.
Precisely. And this happens much more often under certain conditions, especially when it's hot and dry.
Why then specifically?
Because in hot, dry weather, plants close down the little pores on their leaves, the stomata, to conserve water. It's a survival mechanism. But closing the stomata means CO2 from the air can't get in easily, so CO2 levels inside the leaf drop. At the same time, the light reactions are still chugging away, producing oxygen inside the leaf. So you get this internal environment with low CO2 and high O2.
And that's when Rubisco makes the wrong choice.
It starts binding with oxygen much more frequently. And photorespiration is just, well, it's hugely wasteful. It consumes ATP and NADPH. It releases already fixed carbon as CO2, and it produces a toxic compound, phosphoglycolate, that the plant then has to spend even more energy detoxifying and recycling. It can easily slash the plant's overall efficiency by 20–50% in warm climates. It's a major problem inherent in the core enzyme.
Which naturally led evolution to come up with some clever workarounds, these carbon concentrating mechanisms, or CCMs.
Exactly. Biology finding ways to fix the flaws in its own design. The two most famous solutions are C4 photosynthesis and C photosynthesis.
Let's take C4 first, found in plants like corn, sugarcane, sorghum, very productive crops. How does C4 work? It uses spatial separation, right?
Right. C4 plants have evolved a special leaf anatomy called Krantz anatomy. They have two distinct types of photosynthetic cells arranged in layers. The outer layer, the mesophyll cells, is where CO2 first enters the leaf. But instead of using Rubisco right away, these cells use a different enzyme called PP carboxylase. PP carboxylase is great at grabbing CO2 even at low concentrations, and crucially, it has basically zero interest in binding oxygen. It attaches the CO2 to a 3-carbon molecule, PEP, to form a 4-carbon acid.
Hence the name C4. Okay, so they make this 4-carbon acid in the outer cells. Then what?
Then they actively pump this 4-carbon acid into the deeper layer of cells, the bundle sheath cells, which surround the leaf veins. Once inside the bundle sheath cells, the 4-carbon acid is broken down, releasing the CO2 again.
Ah, so they're creating a super high concentration of CO2 right inside those deep cells.
Exactly. They create an internal CO2 concentration maybe 10 to 20 times higher than the outside air. And these bundle sheath cells are packed with Rubisco. By flooding Rubisco with CO2 in a low oxygen environment, they basically force it to act as a carboxylase, minimizing that wasteful photorespiration. It's a biochemical CO2 pump.
Very clever. Spatially separating the initial capture from the final fixation. What are the other strategies? CM, found in cacti, succulents, pineapples.
CAM, crassylation acid metabolism. If C4 uses spatial separation, CM uses temporal separation, time-based separation.
How does separating things in time help with water loss?
CAM plants live in extremely dry environments, often deserts. Opening stomata during the hot, dry day would lead to lethal water loss, so they keep their stomata tightly shut all day long. They only open them at night when it's cooler and more humid. During the night, they take in CO2 and fix it using PE carboxylase, just like C4 plants, making those 4-carbon acids, mostly malic acid. But instead of pumping it to other cells,
They store it.
they store huge amounts of this acid, usually in the cell's large central vacuole, overnight. The cell sap becomes quite acidic. Then during the following day, with the stomata closed to save water, they break down the stored malic acid. This releases the CO2 internally, right next to Rubisco. The light reactions are running, providing ATP and NADPH, and the internally released CO2 feeds the Calvin cycle, so they photosynthesize during the day using CO2 captured the previous night.
Wow. So they basically hold their breath all day and do their CO2 uptake only when it's safe at night.
That's a good way to put it. It drastically reduces water loss, allowing them to survive in places most other plants couldn't.
And the sources even mentioned a newer sort of emergency mechanism, alarm photosynthesis.
Yeah, this is a fascinating, more recently understood thing, seen in plants like amaranthus under sudden, severe drought when the stomata are slammed shut. If they run out of internal CO2 completely, they seem to be able to tap into another internal carbon source, calcium oxalate crystals, which are quite common in plant tissues.
They're mining their own crystals for carbon.
It seems so. An enzyme can apparently break down the oxalate to release CO2, providing a temporary emergency carbon supply to keep photosynthesis ticking over just enough to survive a short, intense drought until the stomata can reopen. It just shows that evolution is still tinkering, still finding ways to optimize and cope with the limitations of this fundamental process.
It's amazing how intricate this all is, and it took us centuries to even begin figuring it out. Let's briefly trace that history of discovery. It really highlights how science works step by painstaking step.
It really does. We can go way back to the 1600s to Jan van Helmont. He did that famous experiment growing a willow tree in a pot for 5 years. He weighed the tree in the soil at the start and end, and found the tree gained a huge amount of weight, while the soil lost almost nothing. He concluded the mass must have come from the water he added.
Which was partly right, but missed the air component. Still a big step away from thinking plants just ate soil.
Definitely. Then fast forward to the 1770s with Joseph Priestley in England. He was doing experiments with sealed jars, candles, and mice. He found that a candle would burn out or a mouse would die in a sealed jar, but if you put a sprig of mint in there with them, the air somehow became restored, and the candle could burn again or the mouse survive longer. He realized plants released something vital.
Oxygen, though he called it dephlogisticated air. And then Jan Ingenhuis, just a few years later, showed this restoration only happened when the plant was in sunlight.
Yes, Ingenhuis nailed the light requirement in 1779, and then around 1796, Nicolas Theodore de Saussure put it together more quantitatively, showing plants gain weight by taking up both CO2 and water. So by the early 1800s, the basic ingredients were known, but not the chemistry.
The real chemical insights had to wait until the 20th century and new techniques, like Cornelis van Niel's work in the 1930s.
Van Niel was crucial. Working mainly with photosynthetic bacteria, not plants, he proposed that photosynthesis was fundamentally a redox process where hydrogen from some donor molecule, H2A, reduced CO2. He generalized the reaction and, importantly, based on his bacteria using H2S and releasing sulfur, he hypothesized that in plants using H2O, the oxygen released must come from the water, not the CO2.
A hypothesis brilliantly confirmed by Robert Hill shortly after.
Yes, the Hill reaction, late 1930s. Hill managed to isolate chloroplasts and showed they could produce oxygen in the light even without CO2, as long as they had an artificial electron acceptor. That proved unequivocally the oxygen came from water splitting.
A major piece of the puzzle solved. And then the final big piece, mapping out how the CO2 actually gets turned into sugar.
That was the monumental work of Melvin Calvin, Andrew Benson, and James Bassam at Berkeley, starting in the 1940s. They used the brand new tool of radioactive carbon-14 as a tracer. They'd feed it to algae as radioactive CO2 for just a few seconds, then kill the algae and analyze all the molecules to see where the radioactivity ended up first. By doing this over different time points, they painstakingly mapped out the entire sequence of reactions, the cycle that now bears Calvin's name, the C3 cycle. Huge achievement, Nobel Prize work.
And it was only after the C3 cycle was established that scientists in the 1960s, like Hesketh and El-Sharkawi, noticed some plants, like maize, had way higher photosynthetic rates than predicted by C3 limits, especially in highlight.
Exactly. That observation led to the discovery of C4 photosynthesis, the Krantz anatomy, the role of PEP carboxylase, realizing that evolution had actually found more than one way to do carbon fixation efficiently.
So let's tie this all together. We've gone from quantum jumps in chlorophyll to global terawatts, from ancient bacteria to modern corn. What's the big picture takeaway here?
I think the main thing is that photosynthesis is this incredibly ancient, deeply sophisticated process. It relies on specialized molecular machinery, precise membrane architecture, even quantum physics, all honed over billions of years to capture sunlight and use it to build life. It's the foundation.
And the evolution of things like C4 and CAM really underscores that relentless pressure to optimize, doesn't it? To overcome the limitations, like Rupesco's flaws, imposed by the environment or even by the system's own components.
Absolutely. It shows biology isn't static. It's constantly adapting, engineering solutions. Which brings us to a really fascinating point from the sources, this idea of kleptoplasty.
Right, those sea slugs like Elysia chlorotica, they eat algae, but instead of just digesting everything, they steal the chloroplasts.
They steal them intact and incorporate them into their own digestive cells. And these solar-powered slugs can then survive for months just using sunlight, photosynthesizing with stolen equipment.
It's bizarre. And the truly wild part is that for this to work long term, the slug seems to need genes to maintain the chloroplasts, and evidence suggests some key algal genes might have actually transferred horizontally into the slug's own DNA.
Exactly. Which leads to a really provocative final thought for you, the listener. If nature has already figured out how certain animals can basically become part plant, hijacking this photosynthetic machinery, how far are we from truly learning from and maybe even mimicking that efficiency? Could we harness the lessons of the quantum walk, the proton gradients, the carbon concentrating tricks to create truly effective artificial photosynthesis for our own energy needs?
A biological blueprint for sustainable energy, perhaps, something definitely worth thinking about.
Okay, let's unpack this. We are about to delve into a world that, well, it should feel both ancient and actually alarmingly relevant. We're looking at the true crime landscape of 17th century China, but it feels surprisingly modern. And we're not just looking at history here, are we? This is almost like human nature codified, turned into a manual.
That's exactly it. What we have isn't just, a random collection of stories. It's a meticulously organized criminal manual, a genuine Crook's playbook, you could say. We are diving deep into the Book of Swindles. It's a collection put together in the late Ming Dynasty by a writer named Zhang Yingyu. He was active around 1612 to 1617.
Just think about that. A historical source that actually categorized fraud. 24 distinct types, cataloged across 84 really detailed stories. And Zhang Yinyu's goal wasn't like to celebrate crime, right? He framed it as a survival guide.
Absolutely. A vital survival guide for what he explicitly called an age of deception. He basically saw that society itself, information within society, could be weaponized.
Yeah, that's really the core insight. The book's premise, laid out right there in the introduction, it's intensely pessimistic and pragmatic. It was meant to help you, the reader, guard against duplicity, because in the unstable world Zhang described, every stranger is a potential enemy.
Wow, every stranger is a potential enemy.
Yeah, so our mission today is really to pull out the universal, the timeless lessons this ancient guide offers about, well, human vulnerability. Because honestly, when you strip away the specific historical context, the silk robes, the silver ingots, the underlying psychological manipulation, it's exactly what we still see today.
Let's start with that worldview then, because that level of mandated cynicism, that trust no one attitude, it really suggests something fundamentally unstable was going on in the social fabric. Well, Zhang Yingyu's description of his own society, it paints this picture of pervasive distrust. It just permeates daily life. He stated, pretty bluntly, that words and appearances mislead. And he warned that the markets, the supposed hubs of commerce and prosperity, they actually teem with frauds.
Team with frauds. So the danger wasn't just theoretical.
Not at all. He urged caution because, as he put it, one steps out the door at one's peril.
One steps out the door at one's peril. That sounds like the world outside your own home was basically deemed hostile territory.
Mm-hmm.
What was going on in the late Ming that made this level of, well, paranoia seem not just reasonable, but maybe necessary?
It seems to be a combination of things. Economic instability, for one, especially with the massive influx of silver coming in from the New World that really destabilized the old financial structures, and also declining central authority. As the Ming Dynasty began its slow, century-long decline, the old social contracts started weakening.
Ah, okay, so when the established systems break down.
Exactly. When Zheng Yingyu says, trust no one, he's reflecting a society where the established systems, justice, community protection, they were failing. People were increasingly relying on strangers for business, for travel, and this leads to the rise of a really key social concept for understanding this period, the jiang.
Right, the Jianghu. I find this concept absolutely fascinating. It translates literally as rivers and lakes, but it's so much more than just geography, isn't it?
Oh, much more. Can you elaborate on why this term is so central to understanding the criminal mindset, or maybe just the mindset of the time?
Well, the Jianghu isn't a place you can really point to on a map. It's a critical social milieu. You could call it a transitory space of indeterminate geography and fluid identities.
Hmm.
It represents the world of movement. Think riverboats carrying goods and people, roadside inns, bustling market areas far from the safety of your hometown. It's the realm of merchants, itinerant monks, traveling scholars, and crucially outlaws, marginal figures who've kind of shed their established identities. So it's a space where the normal rules of settled life are sort of suspended,
Yeah.
and verifying who someone is becomes almost impossible.
Precisely. In the Jianghu, identities are fluid. And the overarching maximum, the survival manual's first principle, really, is that people are often not what they seem. When you're traveling on that riverboat or sharing a meal at an inn or doing business outside your local network, you are stepping into the Jianghu. And you're immediately vulnerable to strangers who have perfected, well, strategic deception.
And what's really striking is that Zhang Yingyu didn't just treat these as, petty swindles, low-level street crime. He elevated them. He saw strategy in them.
He absolutely did. He connected the dots very clearly. The techniques of deception he chronicles in the Book of Swindles, they explicitly call back to classic Chinese strategic thinking. Things like the art of war or the later 36 stratagems.
So texts about warfare and statecraft.
Exactly. These ancient texts, they exalted deception ruses, camouflage, feigning weakness as the highest form of warfare and power. They argued that superior insight and strategy, psychological manipulation, could change the fate of empires.
So the same kind of thinking, the same mental discipline that might win a battle or secure a dynasty is now being applied to, what, steal a few ounces of silver from some traveler in a dingy inn.
That's it. It's like the democratization of strategic deception.
Wow.
It really is. While the effect of any single scam might be local, a stolen horse maybe, or a handful of fake silver, when you compile them into these 84 stories, it reveals what the source calls an empire of endemic criminality. The implication is that in the late Ming, strategic deception wasn't just for generals and emperors anymore. It was the essential toolkit for anyone looking to get an edge in, well, civil society and commerce.
And when we look at the actual scams in the book, it seems like they cover the whole spectrum, from really quick, opportunistic hits to these deep, long-term investments in deception.
Yes, absolutely. You could draw a parallel to, say, the American confidence games of the early 20th century. The Ming crooks playbook definitely included both the short con and the big con. The short con was more momentary, right? An opportunistic encounter, designed to take whatever the victim had on them right then and there. A simple street hustle, often relying on speed or distraction.
Okay, and the big con, that sounds like it requires serious commitment.
Oh yeah. The big con required extended time. Sometimes it involved a whole cast of actors, carefully managed sets, multiple stages unfolding over time. The key here is really psychological. Persuading the mark, the victim, to draw on their additional resources, their savings, their reputation, their family wealth, often by appealing to their greed or maybe vanity.
And Zane's collection has both.
It runs the gamut. It shows us these Ming con artists were masters of, well, behavioral economics, long before the term even existed. And it's worth noting, too, unlike some Western confidence artists who maybe preferred not to use force, the Ming crooks, they often employed violence, or at least the threat of it, as just another tool in the box, which really highlights the high-stakes, low-trust environment they were operating in.
Okay, so that sets the scene. A world of distrust, the fluid Jianghu, and deception elevated to strategy. Now, here's where I think it gets really interesting, because the source material shows that crime wasn't just like an aberration. The very structures of Ming society itself seem almost engineered, maybe accidentally, maybe not, to be fertile ground for fraud. Let's start with the economic system. The money itself sounds like a transparency nightmare.
Oh, it absolutely was. The Ming currency system was an intrinsic weakness, just waiting to be exploited. For small, everyday purchases, people used loose copper coins. Standard enough. But for any major transaction, and these are the ones that feature most heavily in the Swindle stories, they used silver.
Okay, silver. But this wasn't like government-minted coins with a guaranteed value, right?
Right.
That seems to be the crucial point.
Absolutely no standardization. None. Silver circulated unminted. It came in ingots or just lumps of various shapes and sizes. So any major transaction required not one, but two really complex steps. First, the silver had to be carefully weighed, usually measured in liang, or ounces.
Okay, weighing it. Makes sense.
But that was only half the battle. The massive opportunity for fraud lay in what we can call the purity problem.
The purity problem, meaning...
Meaning the actual silver content, the alloy purity, varied wildly. It could be under 70% silver, or it could be nearly 100% pure. Just imagine if every time you bought a house or paid a major tax bill, you had to hire an assayer on the spot to test the metal content of your payment.
Yeah, that would grind everything to a halt, or open up huge loopholes.
Exactly. The lack of standardization created this massive systemic room for fraud. This is Zhang's Type 14, fake silver. If a swindler could pass off, say, a 75% pure ingot as if it were 95% pure, they instantly gained a huge, almost untraceable profit margin. The sheer complexity of just knowing the value of your money created the vulnerability.
So if you were a merchant traveling, you weren't just worrying about highway robbers. You were worrying about sophisticated, specialized knowledge about metallurgy. Your vulnerability just shot up the moment you stepped into a big transaction with a stranger.
Precisely. And this vulnerability, it extended right into the rituals people developed to try and handle large sums safely, especially when transacting outside the public eye, like exchanging a major bribe or making the final payment for some high-value goods.
Tell us about this sealing ritual. It sounds like it was meant to be the ultimate safety mechanism, the way to guarantee trust.
It was intended that way, yes. But it became what the source calls an escrow trap. Here's how it worked. When a large amount of silver was exchanged, say 50 or 100 ounces, both parties would weigh it, agree on the amount and purity. Then it was placed in a container. That container was then carefully closed, wrapped with paper strips, and sealed. Critically, it was sealed with the stamps or chops of both parties involved.
Okay, so the unbroken seal with both stamps was supposed to be the absolute guarantee, proof that the funds inside were secure and hadn't been tampered with.
That was the idea. But because it's a ritual relying entirely on appearances, on the integrity of the seal, it was immediately targeted for manipulation by clever crooks.
Of course, if the trust is in the seal, you fake the seal.
Exactly. The ritual was complex, involving multiple steps all designed to build and confirm trust. But that very complexity gave the swindlers the chance to introduce decoys, fakes. The story titled "Silver with Sham Seals is Switched for Bricks" is the perfect example. The crooks had mastered the art of creating fake seals and packaging that looked completely authentic. The victim believed the ritual, the sealed container, protected them, only to discover later, maybe days later, that the container they'd carefully guarded held worthless stones or bricks instead of silver. It was a direct violation of that formal, ritualized trust.
Wow. Okay, so the financial system was vulnerable. What about the state itself? The government institutions. Zhang Yingyu sees equally cynical about them.
Oh, yes. He reserved some of his harshest warnings for the government institutions. The local administrative office, known as the Yamen, was branded by Zhang Yingyu himself as a thicket of swindles.
A thicket of swindles. That's quite a phrase.
It is. He basically advised readers, avoid the Yamen at all costs. He noted that most ordinary citizens already preferred to keep away entirely because trying to seek justice there often meant just walking straight into another scam.
And we know something about the structure, right? The official magistrate, the judge, he was usually an outsider, appointed for only a short term, like 3 years, and forbidden from serving in his home district to prevent local bias or corruption.
That's right, a structural safeguard, perhaps.
But that structure must have massively empowered the permanent local staff, wouldn't it?
Tremendously. The people we actually see perpetrating these Yamen scams in the book, they're rarely the high-ranking officials, the magistrates. They're the low-level staff, the clerks, the runners, the constables, the people handling the paperwork day in, day out, who knew all the rules and procedures inside out. These individuals were the real interface between the populace and the state. And crucially, they were hired locally. They understood the permanent vulnerabilities of the system, and they knew exactly how to navigate and manipulate the legal machinery for their own personal gain.
They were the system's weak link. And they knew it.
They absolutely knew it.
There's a brilliant anecdote in the source that shows just how deep this manipulation could go. The flogging gambit. This one didn't target greed, did it? It targeted the structure of authority itself. It manipulated even a famously incorruptible official like Judge Bao.
Oh, this is a masterclass in psychological manipulation. Judge Bao, he was legendary, famed as an official of incorruptible morals and keen discernment. Someone who stood for absolute, unwavering justice. So the case involves this rich playboy caught, I think, in a case of fornication. He knew Judge Bao would convict him, no question, so he bribed one of Bao's own veteran officers to execute this very strange, very counterintuitive plan.
Right. The officer's job was basically to appear overly zealous, to overstep his bounds. But really, he was setting a trap designed to trigger the judge's ego, his deeply held bureaucratic principles.
Exactly correct. So when the criminal was brought before the bench, this veteran officer immediately starts loudly reprimanding the criminal, yelling things like, "You've got nothing left to say. Go on and take your beating. You are guilty and you are not getting off." He was acting like he had already passed judgment.
Why on earth would the officer do that? That
Yeah.
sounds like he's just asking to be punished himself.
He was, but he was counting on the predictable reaction of a powerful, status-conscious bureaucrat like Judge Bao. Bao, known for his obsession with upholding strict discipline and his own singular authority in the courtroom, was apparently enraged. But not because he disagreed with the sentiment. He probably agreed the guy was guilty. He was furious that a mere subordinate had overstepped his authority, addressing the criminal directly, attempting to usurp the judge's sole power to sentence.
Ah, I see. So, to uphold the principle of his own authority, Bao had to punish the officer. It wasn't about the crime anymore. It was about protocol.
Precisely. To demonstrate his absolute control over the court, Judge Bao immediately ordered, I think it was 20 strokes of the cane for the officer, for his arrogance, his usurpation of judicial power. And then this is the critical part. He deliberately deducted 20 strokes from the criminal's intended punishment. Why? To further reinforce that only he, Judge Bao, determined the severity of the sentence, no one else.
So the officer takes a minor beating he was probably handsomely bribed for. The rich playboy gets his sentence effectively halved. And the famously incorruptible Judge Bao walks away believing he upheld the integrity of the law and his own authority.
That's the genius of it.
Yeah.
The officer used his intimate knowledge of his chief's character specifically, his need to project absolute control to completely subvert justice without the chief ever realizing he'd been played. And the source material connects the dots explicitly on this. It says, basically, whenever a Yamen officer engages in this kind of treachery, it's because he understands his chief's character and can manipulate it to his own ends. It shows that structural weakness isn't just about bad systems, it's about people who understand the psychology of power and know how to exploit it.
That story, manipulating structural ego, it provides a perfect transition, actually. If that last section showed us how systemic flaws, like in a currency or the courts, invited corruption, this next section really showcases the sheer brilliant ingenuity of the crooks themselves, applying high-level strategic thinking to exploit raw human weakness, things like greed, vanity, simple carelessness. Let's start with a classic short con, one that relies on building trust quickly, only to immediately betray it. It's type 1, handing over silver before running off with it.
Right. This is a beautiful little case study in strategy and counter-strategy. It shows not just the scam, but also how to potentially defeat it. So you have a successful fabric dealer named Su Guang, and he's traveling home. He meets this younger man, Ji Sheng, who's described as a greenhorn crook, but he uses this really ingenious technique to build immediate trust. Ji Sheng actually entrusts Su Guang with 20 ounces of his own silver. He asks Su to store it securely in Su's trunk for safekeeping overnight.
Okay, wait. Ji Sheng is giving his own money to the potential victim. That's counterintuitive. He's making a financial investment in building trust.
Exactly. He's putting his own money on the line to convince Su that he's a partner, a fellow traveler, not a threat. Su is now psychologically invested, right? He feels responsible for protecting Ji Sheng's money alongside his own.
Ah, okay. So Ji Sheng's plan is?
Simple but clever. Once Su is asleep, he plans to steal the entire trunk, which contains not only Su's much larger fortune from selling fabric, but also Ji Sheng's initial 20 ounces. He gets his investment back, plus a huge profit. Later that night, Ji Sheng pretends to have diarrhea. He keeps opening and closing the door, supposedly heading to the latrine outside, but really he's checking if Su and his son are sound asleep.
Okay, seems like a solid plan, but the story describes Su Guang as an old hand, someone who lives by that Jianghu maxim. Trust no one.
He maintains absolute mandated suspicion. The moment G steps out for one of his supposed bathroom breaks, Sue confirms his suspicions. He doesn't hesitate, he acts quickly. He secretly removes all the real money, both his own considerable sum and G's 20 ounces, and hides it all in a bundle of clothing right under his pillow. Then he refills the large, heavy trunk with bricks and stones.
Oh, I love that twist. So the greenhorn crook gets exactly what he planned for. He feels a weight, assumes it's the silver.
Yes, he gets the heavy trunk, confirming the presence of money in his mind, but he's actually stealing worthless ballast. So Zhisheng steals the heavy trunk, makes off into the night, convinced he's struck it rich. The next morning, naturally, Sue raises a ruckus about the theft. And later, Zhisheng, who must have discovered the bricks by then, is apparently foolish enough to return to the same area. He gets recognized, captured, beaten up by the innkeeper, and ends up losing his initial 20 ounces of silver to the innkeeper as compensation for all the trouble.
The source material almost sounds gleeful here, doesn't it? It concludes that Zhisheng's scheme, giving temporarily in order to steal in the end, was ingenious in theory, but ultimately, a bright greenhorn crook is no match for the seasoned man of the world.
Yeah, the lesson is hammered home. Suspicion, constant vigilance is the ultimate defense. And it's a powerful lesson not just for Ming Dynasty travelers, but for us too, right? That willingness to accept a small initial risk or gift from a stranger like Zhisheng's silver that can be the bait, it triggers greed or maybe just lowers your defenses enough for the real con to land.
Okay, so that was exploiting trust built on greed. Now let's move to a scam that targets something more subtle, but maybe even more powerful, especially in that society, vanity. In the status-obsessed Ming world, the civil service exams were everything, right? The ultimate path to social advancement. How did a crook turn that aspiration into cash?
This is forged letters from the education intendant, report auspicious dreams, type 4. And it specifically targeted the families of successful provincial exam candidates. These guys were called jurin. They'd passed one major hurdle and were now preparing for the even more important national exams in Beijing. Status seeking, as the text notes, was at a fever pitch in this world.
So they weren't targeting the poor or necessarily the overtly greedy here. They were targeting educated families, people obsessed with pedigree, reputation, getting ahead.
Exactly. So a crook partners with a skilled calligrapher. They forge these exquisite official-looking letters. They even seal them with a sophisticated-looking fake stamp. The letters claim to be from a highly revered, real education intendant, a Master Shen. And they claim that Master Shen had these prophetic, auspicious dreams, predicting that the family's candidate would rank first in the upcoming national examinations.
Wow, first place. And the detail they put in is incredible, isn't it? They actually tailored the dream to the family name.
They did. For the Sheng family, the dream featured a flying bear, because Yishang means bear and gilded characters reading first place. That level of personalization, that seeming divine insight linked to their own lineage, must have felt utterly convincing, irresistible even.
So the crook delivers this strictly confidential good news.
Right, strictly confidential, very important detail. And the families, the text describes them as being recklessly obsessed with status seeking. They were just ecstatic, overjoyed. They didn't question it. Why would they? It confirmed their deepest hopes. And they happily paid large tips, sometimes 3 ounces, 5 ounces, even 10 ounces of silver in one case mentioned, just for the promise of future glory. The total takings from this one scam run apparently exceeded 100 ounces of silver.
It makes you wonder, though,
Yeah.
if the victims were actually happy to pay the money, believing they were, I don't know, securing or confirming a powerful future.
Yeah.
Were they truly victims in the traditional sense? Or was this essentially a service transaction, selling a hope and confirmation bias?
That's the psychological brilliance of it. The text even calls it a painless scam. The families weren't left impoverished or physically injured. They paid for months, maybe, of glorious anticipation. They got to believe what they desperately wanted to hear. The crook basically sold them a validated fantasy. Their focus was so absolutely fixed on the outcome, the status, the rank, the respect, that they willingly ignored or didn't even consider the fraudulent means. In a way, they were willing buyers in their own deception, which feels somehow more terrifying than a simple street robbery.
That failure of attention, that fixation on one's own desires and status, leads us directly to the next classic con, doesn't it?
Yeah.
Exploiting a simple lack of vigilance. Type 3. A Taoist in a boat exchanges some gold.
Right. This involves a student named Fei. And he starts out by boasting, actually. Despite a friend's warning, he insists he's far too clever and learned to ever be swindled. And initially, he proves it. He successfully negotiates and buys a pure 12-ounce gold ingot at a pretty favorable price. He's so cautious during the actual transaction that the original seller doesn't get a chance to switch the gold for a fake.
Okay, so his initial diligence works. He proves his cleverness, he feels validated. But then, complacency sets in.
And complacency is absolutely lethal in the Jianghu. So the original gold seller's father, cleverly disguised as this very eloquent, charming Taoist priest, manages to board Fei's riverboat shortly after the purchase. Over the next couple of days, this Taoist charms everyone on board. He subtly steers the conversation around to the topic of authenticating precious metals, gold, silver, that sort of thing. And Fei, bursting with arrogance, wanting to show off his prize and his discerning eye, pulls out the pure gold ingot he just bought. He wants to demonstrate his superior purchasing skills to everyone.
He's undone by his own need for validation. His vanity again.
Completely. So every passenger looks at the gold, admires it, verifies its quality. The Taoist priest is strategically the last one to inspect it, and he does so just as dusk is falling, in the dim light of the boat cabin. In that momentary lapse of light and attention, the student Fei, probably basking in the compliments, not watching the ingot like a hawk anymore, the Taoist effortlessly switches the pure gold ingot for a worthless copper copy that looked identical. A perfect switch.
And Fei doesn't realize.
Not until he gets home, hours or maybe even days later. He takes it to a craftsman, maybe to have something made, and the craftsman immediately points out it's just copper,
Right.
a massive loss discovered far too late.
What's the lesson the source draws from this one?
It's absolute and quite stark. Initial vigilance is no substitute for constant vigilance. One can't let one's guard down day or night. If he's boasting, his relaxing of his guard after the successful purchase, that's what created the opening. It allowed the sophisticated, high-stakes switcheroo to happen. The text even compares his mistake to, like, carrying a full jug of water all the way from the river, only to smash it right as you reach the well. Failure at the final critical moment due to arrogance and carelessness.
Okay, finally, let's look at what might be the most calculating, perhaps even the cruelest story in the playbook. It perfectly blends psychological insight, manipulation of religious belief, and pure, ruthless necessity. Type 21. A Buddhist monk identifies a cow as his mother. This sounds like a truly multi-layered big con.
Oh, it is. It's a complex narrative, really unfolds in 3 parts. And it starts with a simple yet brilliant observation by an itinerant monk. He sees a boy's cow licking the boy's sweaty leg. The boy's leg is salty. The monk realizes instantly. The cow craves salt. Salt was a highly valuable, sometimes scarce commodity in Ming China. This simple observation is his key insight into the animal's behavior.
Okay, step 1. Understand the basic drive, the weakness. In this case, the cow's need for salt.
Step 2. The psychological play on the human. The next day, the monk prepares. He covers himself, his face, his shaved head, in thick brine-concentrated salt water. Then he goes to the cow's owner, a humble husbandman. He weeps, puts on this incredible performance, claiming the cow is actually his own mother, reincarnated and suffering for her past sins by being reborn as a beast of burden. He claims he needs to save her soul, take her away to care for her.
Wow. That's a direct appeal to core beliefs, isn't it? Religious belief in reincarnation and the absolute duty of filial piety, central tenets of Chinese society.
Precisely. The husbandman is naturally moved by the monk's apparently heartfelt speech and tears. He takes the monk to the barn to see the cow. There, the monk removes his cap, cries out, "Mother!" and kneels dramatically before the yellow cow. And the cow, smelling the thick layer of salt brine he's covered in, immediately does what? It begins licking him intensely all over his head and face. It looks incredibly affectionate, maybe even like it's weeping too, as if it genuinely recognizes its son.
So to the husbandman, who's probably superstitious, devout, this must look like absolutely irrefutable, maybe even divine proof, a miraculous recognition.
It sealed the deal. Completely convinced by this apparent miracle, the husbandman gives the monk the cow, tells him to take it to his mountain chapel and care for his mother.
Okay, but the monk's piety is instantly revealed as a total fraud, right? What does he actually do with the cow?
He keeps the cow until winter sets in, then he slaughters it. He makes beef jerky from some of the meat and sells the rest. His mother becomes provisions.
And that jerky becomes the crucial tool for the final, biggest con in this sequence.
Exactly. He then travels to the house of a rich, influential local man. He presents himself as an immensely devout Buddhist practitioner. He claims he's been successfully fasting for 3 whole years, achieving great spiritual merit, and has now returned specifically to help save this rich man from some unspecified karmic debt. To prove his extraordinary piety and gain the rich man's complete confidence, he agrees to perform a public fast right there in the rich man's house for 1 full month.
While secretly surviving on the beef jerky he made from his mother.
Absolutely. He's given only boiled water publicly. But secretly, hidden inside the folds of his flowing monk's robes, he's eating the dried, salted beef. The rich man is, of course, completely astonished by this feat of endurance. He's convinced this monk possesses immense spiritual power, maybe even sainthood. He desperately asks how he can clear his own karmic debt. And the monk, having now fully established his spiritual authority through deception, suggests a substantial donation. 500 ounces of silver, supposedly to finish construction of a hermitage on the famous Mount Lu.
The rich man pays.
He pays. The monk takes the huge sum of money and naturally vanishes.
That's incredible.
The source material itself is pretty blunt about this one. It calls it a crime that reaches all the way up to heaven. It concludes that the monk used his faked fasting, enabled by the jerky from the swindled cow, to commit this massive fraud, playing ruthlessly on the necessity of the cow, its need for salt, the husbandman's piety, and the rich man's fear of karmic retribution. It's a stunning display of calculated malice and incredibly staged psychological manipulation. Hashtag tag outro. So when we step back and connect all these dots, what does it all really mean? When we look back at the Book of Swindles, its value isn't just, as a historical snapshot of Ming Dynasty crime. It really provides this unvarnished diagnosis of human nature, one that seems to completely transcend the 17th century.
Yeah, it seems like the successful cons we've talked about, from the silver switch with the fake seals to the flogging gambit targeting Judge Bell's ego to the monk and the cow, they relied consistently on predictable, timeless human frailties, didn't they? Greed, obviously, vanity, the intense pressure of status seeking in that society, the desire for shortcuts, whether it's for wealth or spiritual salvation, and maybe that fatal belief that your own cleverness or your social standing somehow makes you immune to deception.
Exactly. And the enduring relevance of this guide, the Book of Swindles, it's kind of proven by history itself. We know its popularity actually surged again in later periods of Chinese history, specifically during times of intense political turmoil, failed modernization efforts, rapid urbanization, periods like the late Qing Dynasty, the Republican era in the early 20th century, and even after the reform period started post-1976.
Really? So when things got unstable again, people reached for this book.
It suggests that whenever social trust erodes, whenever that uncertain space of the Jianghu expands in society, guides to spotting scams, guides to navigating deception, they become essential reading again, required for public survival almost.
It really seems like a core finding here, maybe the most uncomfortable one, is that the victim often participates, sometimes quite willingly, in their own downfall. You think about the student Fei boasting about his gold ingot. The family's completely obsessed with exam status, willing to pay for good news. The rich man looking for a spiritual shortcut to clear his karma. They all lowered their defenses, didn't they? Often because they were looking to get something extra, an advantage, a compliment, a discount, a guarantee, rather than just focusing on, rectitude and due diligence.
The source material itself contains a really strong warning about exactly that. It warns against victims who sought quick gains or easy answers, stating flatly, "Desire for profit makes even the wise foolish." It implies that if those Ming scholars and merchants had just focused on honesty, on genuine effort, on maintaining constant vigilance in their legitimate dealings, well, they would have been impervious to the vast majority of these sophisticated schemes we've discussed.
Which raises a final, maybe provocative thought for you, the listener, to consider. Could it be that the greatest, most enduring lesson from the Book of Swindles isn't really about the admittedly genius tricks of the crooks? Could it be more about the timeless moral failings, the predictable psychological weaknesses of the mark? Maybe the crooks merely provide the catalyst, the test, but it's the mark ultimately who provides the opportunity.